All right, in this lesson we're going to talk about balancing equations. Our goal in balancing equations is to have an equal number of atoms on both sides. So in this little picture I have two H's, so I have to have two H's on the other side. I have one oxygen, I need to have one oxygen on the other side to make it balanced. All right, the steps when balancing equations is first you're going to count your atoms. Then you're going to ask, are they equal? If the answer is yes, then you're finished and you can move on. If the answer is no, you have to add coefficients and then recount all your atoms and then circle back around. Are they equal? No, add coefficients, recount, circle back around. This step here can take you a couple of tries before you get to yes and being done. So don't worry if it's taking you more than one step or two steps. It can sometimes take a while. So here's an example. P4 plus O2 yields P2O3. So my phosphoruses don't match and my oxygens don't match. So nothing is equal. So I'm going to now add coefficients. So let's look at this one first. 4 and 2. So I need to think to myself, 2 times what will give me 4? So 2 times 2 equals 4. If I put a coefficient here, or if I multiply by 2 here, I have to also multiply by 2 down here. Because this is the same molecule. So I can't add a coefficient here and not also apply it to the oxygen. So that gives me 3 times 2 is 6, 2 times 2 is 4. So now my phosphoruses match up, but my oxygens are wrong. So now I say 2 times what will give me 6. All right, so now I count my atoms again. 4 and 4, 6 and 6. So now all my atoms are equal on either side, and I just need to add my coefficients to the equation. So here I multiplied by 3, and on this side we multiplied by 2, and that is a balanced equation. Okay, here's another example. So I've gone ahead and counted my atoms up, and on this side you notice I have oxygen, 2 oxygens, and 1 oxygen. And I find it easier if you separate those two instead of combining them. Ultimately, you need to add them together to see if your equation is balanced, but it's easier to work with if you keep them separated. So let's just start with our hydrogens. All right, so 2 times what will give me 4? And because this hydrogen is attached to this oxygen, the single oxygen, I also have to multiply this by 2. All right, that gives me 4 and 4, 1 and 1 still. Now I have 2 plus 2 more oxygens for a total of 4. And on this side, I have 2 oxygens. So I think to myself, 2 times what equals 4? 2 times 2 equals 4. Here's my coefficient. It goes there. This is my coefficient on the other side. It's going to go right there. And now I have a balanced equation. Alright, this next one here is pretty hard. So we're going to take a second, copy it down before you move on with the video. It is Al, aluminum, Br3 plus K2SO4 yields KBr plus Al2 SO4 3. So I went ahead and counted up my atoms. 1, 3, 2, 1, 4, 1, 1, 2, 3, 12. Alright, so they're not matching up and they're not equal yet. So let's start with our oxygens. I have 12 and 4 on this side. So 4 times what will give me 12? 4 times 3 equals 12. That's this oxygen right here. So I also need to multiply by my S by 3. And I need to multiply my K by 3. All right, let's recount our atoms. 12 and 12, 3 and 3, 6 and 1. All right, so let's go to our potassiums, our Ks. 1 times what equals 6? Like that. All right, this K is here. So because this bromine is attached to it, I have to multiply this by 6. All right, so now bromine has 6. And on this side, bromine has 3. So 3 times what equals 6? This bromine is attached to this aluminum. So I have to multiply my aluminum also by 2. Okay, count our atoms up again. Aluminum is 2, aluminum is 2. Bromine is 6, bromine is 6. Potassium has 6, potassium has 6. Sulfur has 3, sulfur has 3. Oxygen is 12, oxygen is 12. So now it is, all the atoms are where I need them to be. I just need to add my coefficients. So aluminum and bromine, there's my coefficient. So I'm going to add a 2 onto that. For K2SO4, my coefficient is 3. So I put a 3. On this side, for the potassium and bromine, coefficient is 6. So I put my 6 there. This molecule here doesn't have any coefficients to add, so we just leave it alone. And this is your balanced equation.